So in this next question, we're shown an AC supply with a VRMS, a voltage root mean square of 5 volts and a frequency of 10 kilohertz. We're shown a capacitor that's 0.0054 microfarads. So we want to determine the RMS current shown in this diagram. Well, rather than write them out in the question, I'll just highlight them here. The micro stands for multiplied by 10 to the power of -6. And the kilo is multiplied by 10 to the power of 3. So you can just make sure you type them in correctly. So the first thing we want to find out there, for determining the current, we're going to have some sort of resistive element of it. And for that, in a capacitor, we're going to calculate its capacitive reactance. So XC is equal to 1 over 2 pi the frequency times the capacitance. So 1 over 2 pi FC. And we just plug in these values. You get 1 divided by 2 pi, and the frequency is 10 multiplied by 10 to the power of 3 hertz times 0.0056 multiplied by 10 to the power -6 farads. You plug those values into your calculator, you get a capacitive reactance XC. The units is going to be in ohms. You'll get 2.84 kilo ohms. Okay, so 2,840 kilo ohms. And then next up, you want to find the RMS current. Well, we have a RMS voltage. We have a capacitive reactance in ohms. So we can actually use Ohm's law. So we just then apply Ohm's law. So applying Ohm's law, V is equal to, normally we say IR, but this time, in this case, we're talking about capacitive reactance. So the ohms is called XC. So it's V is equal to I XC. So you're just getting a current by resistance. And that gives you, we'll just put it in terms that we have it here. V RMS is equal to I RMS times XC. We're just letting you know that they're in root mean squared. So we can transpose that formula and we get I RMS is equal to your V RMS divided by your capacitive reactance. So you plug in those values, we have 5 volts RMS divided by 2.84 multiplied by 10 to the power of 3 ohms. And when you put that in the calculator, you'll get an RMS current of 1.76 milliamps.